Okay, the part two of reactivity series, of course, talk about displacement reaction. So, right, we understand already. Let's give you an example first, right? Mg plus, let's say, CuSO4. Okay, so it's always the element, all right? That means in this case, magnesium, and then want to kick out another metal. Remember, all right, group 17, I mean, metal, kick out metal, uh, a more reactive group 17 displays a less reactive from its compound. A more reactive metal displays a less reactive metal. Right? And you go pick up one thing. So normally, right, that means when we are couple, right, there's two of them already. Normally we don't go and find additional problem. It's always the one that's single, the element that want to displace, and it can only displace if it's more reactive. You know that magnesium is more reactive than copper, then you will get this, you get magnesium sulfate, and you get copper. So the observation, the common observation, metal deposit in this case is your copper. So we can say, okay, copper quite unique. Most of the metals are silver gray in color, but copper is actually reddish brown or pinkish brown. So we can say reddish brown deposit forms. The metal that displays will become smaller. So we can say that magnesium, okay, like become smaller. That can be a second observation, right? Or sometimes we can say it dissolve, okay, appear to dissolve. Now the third, now this one, this third only does okay. This first two is always most of the time if there's a displacement occur in the reactivity for metals, you will see these two observations. But the third one, right, only happens if you use a transition method. So in this case, we can say the blue solution becomes colorless. Right? We know that the blue solution, right, becomes colorless. So the blue solution is actually a copper 2 sulfate. It becomes colorless. Right? That's for the zinc sulfate. Oh, sorry, this is magnesium sulfate. All right, so this one really depends, not happens all the time, depends whether it involve the transition metal compound or not. Right, that's what I meant by the common observations that we can write. Of course, the explanation will be quite similar to group 17, just that now we're talking about metals instead of group 17. All right, the next part is mainly more for the pure chem. Okay, metal carbonate decomposition. So now same thing, we are talking just now, see earlier we were talking about the metal itself, right? Metal react. Okay, so more reactive, of course, will displace. But now we're talking about the compound. Okay, for the pure chem students, we talk about the compound, right? Because it's metal carbonate, not the metal alone. Of course, when you heat, it will become metal oxide and carbon dioxide. And now the opposite things will happen, right? Actually, the more reactive the metal, the stronger the bond. So it will means more energy, and therefore it will take longer time. So take note, doesn't always means that more reactive metal always takes shorter time. Depending on are we looking at the metal itself or the compound. In this case, looking at the compound, then we have to think in terms of compound. All right, and indeed, group one metal, the most reactive metal, all right, because they just need to lose one electron, easiest to lose one electron, they are the most stable. Right? In fact, they do not decompose. Right? So do take note, especially when comparing reactivity theories, especially they give us experimental data, we need to ask ourselves, are they talking about the metal in reaction or the compound of the metal? Okay, that is important to make sure that we are interpreting the information correctly.